Hello everyone. Sorry I wasn't able to make the meeting this evening. I'm going to make this video for you guys to watch, presentation on my STEM project. So my name is Presentation-HONOVIC, and this project is for the Mallet STEM course that we're all taking for Dr. O'Connor at Empire State College. Here you can see an illustration of a ladder diagram, and we're going to talk about that a little bit more throughout this presentation. So the project name, I guess the official name is Industrial Motor Controls. It also follows along with the course that I teach and the course that I'm doing this project for. Didn't really want to get too crazy with the name. It's kind of following along with what the project is directly related to, which is industrial discrete and process manufacturing, mainly focusing on motor controls and discrete control. The intended audience, I did this project with my students in mind, the HVCC ECM students that are taking industrial motor control courses. Hopefully not just my students, but other instructor students as well can view the videos and the project that I've created, and hopefully it helps them out. So moving on to my goals. So hockey nuts, because I'm a huge hockey fan, and the Stanley Cups are over, so I'm sad. But the goal of this project is to help students succeed with ladder logic design and ladder logic programming. So ultimately, we want them to be able to get through programming and make them successfully without having huge issues. Often my students don't have enough time in the classroom to practice, unfortunately, as I'm sure most of you know. Class time can be limited, and some students need the extra help or the extra time. So these videos are intended to help students succeed in the classroom. Particulars, they're going to be able to read a ladder diagram sequence of operations, so there'll be some reading involved as far as the topics that we're going to be doing. So if I say, I want a motor control with a start-stop button using 3-wire motor control, that would be the sequence of operations. They're going to then design a ladder diagram and hopefully understand what they're doing and be able to view my videos that I created for this project to get a better comprehension. So they'll be able to listen, understand, and act upon their understanding within the classroom. The learning environment is going to be a blended learning environment. So on the left, what you can see there is actually the actual classroom that I teach in. This is my shop class over at Hudson Valley, and just to give you an idea, so these are motor starters. Okay, those are 2 motors. Here's a bunch of push buttons and pilot devices, and then that's the actual PLC that we program. These 2 components, this is a VFD and an HMI screen. So not to get too into things, but this can also be used to control the motor. That will vary the speed of the motor in conjunction with the PLC or on its own. And then the HMI typically works in conjunction with the PLC. So those 3 components can be incorporated to work as one unit, as well as using the rest of these. So by giving them that in-class experience and the hands-on learning, and bringing in this e-learning or online environment, I hope to create a blended environment that allows students to take information that they see in the classroom, demonstrations that I do, labs that we do, shop jobs is another word we use for labs, and we're going to bring that out into the e-learning environment to help them create an e-learning environment, which is blended. Sorry. Revisioning the old, they're keeping up with the new. So looking into the future of the program that awaits around the horizon, this image is actually from Australia. These are the Great Keppel Islands, and just figured it was a nice picture to put in there. So, anyways, we're going to be able to try and keep the program up to date. All right, so we got a lot of different applications going on in the different classrooms and the various different disciplines. But for the industrial motor control world, there's really a lot that changes every single year. So to try and keep the kids up to date, try and keep my videos up to date, will definitely be a challenge. But ultimately, we're pretty close to where the industry is today, and we'd like to keep it that way. So make our program attractive to students as well as employers. All right, learning expectations. I kind of mentioned this already in the beginning, but just kind of revisiting it. Learning expectations will be that students will be using the project as a tool in addition to the class. So we're going to expect that they're going to watch these videos either prior to a lesson or following a lesson to better their understanding of the PLC programming and ladder logic. All right, so one example here of how we're going to sequence things. We're going to start with a standard hand-drawn ladder diagram, and you can kind of see my face is a little bit in the way. But here you have your stop, your start, and we're indicating what kind of contacts they would be, or what the state or the position of those switches are, which will help us or help the students when they get into the actual programming. And then they're going to convert that over into the actual PLC program that you said here, which if you've been able to see any of my videos, this might look familiar from GE's prophecy. Assessment is going to take place in class daily. Students usually get a chance to work in lab 2 to 3 days a week, and they're graded on the labs that day. So their assessment will be on a daily basis in a face-to-face environment, and that will be followed up by basically a quarterly or midterm and final comp exam. Some of the technology I used, obviously, Prophecy Machine Edition, and I'm just going to speed this up because I'm running out of time. Google Sites, Screencast-O-Matic, and YouTube as well. Alright, these are some of my references, and thank you very much for your time.